Hi sir, today I will explain how I recorded and analyzed my simulation result in Omnet++ using the step 10C. Firstly, I will show this is my folder. Analysis file includes the Excel file, but I will explain. Firstly, I will choose step 10C, complete various network routing table configured using AODV routing and host 7. Firstly, I run this configuration. Then we will see how I make. Firstly, I was recorded button and then run the simulation. But I can't because I had recorded this Excel file. This folder includes, but I will explain. But we will run the simulation and we will see the output faster. Yeah, we will see this output and communication between the hosts. Then stop the simulation. Now I will show this result Excel file for analysis step 10C. Now I will send this file and I have a many question for overheads in this scenario. Firstly, I sent the ChatGPT, then DeepSeek. I will explain each. Firstly, I will upload. I was upload this AODV protocol result CSV, and I sent step C. Now my question here, and I want fighting code using Matplotlib visualize traffic over time, load variation, the simulation, packet delay behavior. I will show after, but we will see. This graphs is DeepSeek output. Firstly, let me quickly network setup. All the nodes in the simulation were wireless. I used AODV as the routing protocol. Host 1 was communication with host 7, and during the entire simulation a total of 18 data packets were sent. Now here as important point I would like to highlight, as you may know, AODV is an on-demand protocol. This means a node only tries to discover a route when it actually needs to send data, and during the process it generates two types of control message. Firstly, RREQ route request, RRUP route reply. In the simulation, before sending the very first data packets, there was only one route discovery. That means in total just one RRUQ and RRUP were exchanged. Once the route was set up, all 18 data packets were delivered successfully without any interruption. This shows clearly how AODV can keep control traffic to a minimum in static or low mobility network. Now let's quickly calculate the routing overheads. Overhead calculate this ratio. So only about 11% of the total communication was control message, and 89 was real data traffic. Compared to protocol that constantly send control traffic, AODV gives a big advantage here. Now then output this ChatGPT analysis. This fighting codes. Now I will explain. Then now I will show this message. Then firstly I will show these codes and then analyze using ML technique chats. Firstly, in this graph, we see routing overheads. This first graph. We see routing overhead for data traffic over time. Yes. At the very beginning, around 10 to 5 seconds, we notice a small overhead when the route discovery happens. After that, there is no more control traffic, just pure data following through the network. The takeaway here is, once the route is found, the network focuses entirely on data transmission. And then routing overhead becomes basically zero after the initial setup. This perfectly captures AODV's discover once, then use it for a long time strategy. And then another graphs, which shows channel load over time. We will see the channel load increase a little bit first because both control and data packets, but pretty quickly and around 5 seconds. The load stabilizes at around 3 to 4 packets per second. This graph tells us the traffic was managed in a very balanced way, and then no network congestion, packet loss, or major delays occurred. And then last graph about the packet delay over time. We see that the first data packet experiences a high delay, around 2000 milliseconds. That's because the route discovery wasn't finished yet. But once the route was established, the delay drops down to about 30 to 40 milliseconds and stays stable after that. Meaning, initially there is a natural delay to the route discovery. On the other hand, afterwards, the transmission becomes fast and smooth, which is critical for real-time application. Now, about mode mobility. In the simulation, the nodes were static. Once a route was found, there was no need for further discoveries. That kept the routing overheads low and the delay minimal. If the node had been moving, routes would have broken down. Now, RREQ and RREP message would have been generated. The overhead would have increased, and then the channel load would have fluctuated, and packet delays would have spiked. But thanks to the static nature of the network, and everything stayed stable, efficient, and fast. The wrap-up routing overhead was low, around 11%. Channel load stabilized quickly after an initial rise. Packet delays were high only at the very beginning and then stayed low and consistent. Overall network performance was excellent with smooth data transmission, and no mobility related issues were encountered. And then finally, through this project, we learned AODV is a very suitable routing solution for static or low mobility wireless network. And then once a route is properly discovered, long-term interrupted communication is possible. Routing overhead can be minimized with careful design. Data can be transmitted with low delays, optimizing overall performance. Finally, this kind of analysis is really valuable for real-world applications like IoT systems, sensor network, and mobile attack network. Now, I will show analyze using ML techniques question and ChatGPT how send the message and answer. ML technique we will use. ML method purpose k-means clustering and discover different network paths. And then isolation first and local outlier security abnormalities to detect possible anomalies. If you want, we can also logistic etc. Fighting code plan. Start ML pipeline from CSV data. ChatGPT says write these methods. Since our data wasn't labeled, we needed unsupervised learning. Key means helped us automatically group similar behaviors in the network. Isolation force caught rare events like traffic bursts. Standard scaler made sure different metrics, these metrics delay load packets, were on the same scale. This way we could catch patterns that would be hard to spot manually. And then our ML workflow, here is the step by step. And then data preparation, we extract key columns like time, packet sent, channel load, and packet delay from CSV files. Feature scaling, normalize the data using standard scaler. Clustering key means found different network behavior phases. And then anomaly detection, on the other hand, isolation force, detected unusual traffic chains. Then visualization, plotted clusters and anomalies to better understand network dynamics over time. And then I say which ML techniques did you say? ChatGPT says K-means isolation force, standard scale, optimal PSA. Using ML, we went beyond basic stats and revealed hidden patterns and problems inside the network. This approach is extremely valuable, especially for designing nav protocol or improving network performance. And then, in summary, with your data, we are using unsupervised machine learning because there is no pre-classified data. We are going to discover ourselves. Now, I will explain DeepSeek AI how I say. And then I will send same question and same file. This says this output. I will cheat it. DeepSeek AI's advanced analysis approach. First, DeepSeek goes for AODV analysis, move beyond just classifying current states, and then build proactive, future predicting, and adaptive system, and model the network deeply and make smarter decisions in real time. Secondly, key techniques proposed by DeepSeek AI. Firstly, this question LSTM network for time series forecasting. Why LSTM? ARIMA model are good for short-term trends but miss sudden change and complex pattern. LSTM learns long-term dependencies and provides more accurate traffic load prediction. GPT use only ARIMA for short-term, but DeepSeek suggests LSTM to capture dynamic and future behavior. Secondly, graph neural network for the network topology modeling. GPT didn't use any topology-aware models, but DeepSeek brings topology awareness through GNNs. And then reinforcement learning for adaptive AODV. Why reinforcement learning? Networks are dynamic. This is heavy traffic, not mobility, etc. GPT only suggested static adaptive function, but DeepSeek AI aims for a fully learning and self-improving protocol. On the other hand, online learning for real-time adaptation. Why online learning? Immediate adaptation without retraining when traffic changes or nodes disappear. DeepSeek proposes using libraries like River for continuous model updates. Then GPT assumed offline training, but DeepSeek AI enables real-time on-the-fly learning. Now, I will summary in final. This secondly, C for DeepSeek AI. technical differences summary table, and I will found I sent the which ML technique did you use. Then ChatGPT says this summary table for GPT or DeepSeek. So I will explain. Now I will show DeepSeek fighting codes, and we will see these graphs, these fighting codes for DeepSeek. DeepSeek AI sent these codes, and we will see these graphs. AODV routing overhead vs data traffic. We will see these graphs ChatGPT sends. The second graphs channel load variation. This DeepSeek AI sent to us, but these graphs sent to ChatGPT. Any different things, different analysis for these AIs. Last graphs, this packet delay behavior, and then this ChatGPT says. Finally, we will see packet delay behavior graphs for DeepSeek AI. That's all from me today. Thanks you so much for listening.